Well, very good afternoon to all our friends there in the GCC. Assalamu alaikum and namaskar. I hope everybody is doing well. I hope things are getting better, inshallah. And hope is the only strategy that we have. Let me introduce myself. I'm Ahmed, co-founder of WFM. We are a print magazine in India and the Middle East, and also a digital platform. Before I begin the sequence of the presentation and the flow, I would just like to remind you all that this is our 17th webinar across the world, and we've taken a little break in the month of June to re-understand and see, focusing on content and focusing on what we want to do going forward, how to disseminate information. I'm very happy to tell you that we had about 800 registrations for this webinar, and we have from all over the GCC, including all of the UAE, Qatar, Egypt, Iran, Jordan, Lebanon, and also some people from Turkey and so on have also joined. Of course, so we have a little bit of a global audience. I hope that English is the perfect communication methodology today, so that's what we're going to do. So today's webinar is on designing and building high-rise ventilated Rainscreen facades. So in today's session, we're very delighted to have a specialist, Agnes Koltay from Koltay Façades. She heads the business. She's been in Dubai for the last 15 years. She's from Hungary, and she's going to talk about special aspects of designing and building high-rise facades. Followed by that, we have two of our good friends from Fischer Middle East, who will be talking about products. We have Mostafa, who's a technical manager at Fischer Middle East, and probably to just introduce you to them a little bit. Agnes is a master's in architecture from Hungary and a master's in facade engineering from the UK. She's worked with Zaha Hadid. I don't need to introduce that. And she's worked at Meinhardt, Ramboll. So before she started her own service here, she's a consultancy firm, a large practice in the Middle East, very well known, also office in Singapore. So she has all the ultimate capabilities, and I will leave it to her. Of course, as you can see here, she was recently part of the Burj Khalifa project, the Business Bay in Dubai, the Sky View Fountain, the Burj Vista, as well as a lot of other projects around the world. Thereafter, we have Mostafa. He's a technical manager at Fischer from the Middle East. He's a licensed PE backed by 16 years of experience in the construction industry. He was awarded the best manager by Fischer. Mostafa is the well-known person in the region. I guess we have a lot of architects and consultants here in this webinar today. So I guess that you would all know him. He would talk a little bit about himself once he starts. Also, we are joined with Muzaffar Ahmed Syed from Firestop department from the fire range of Fischer. He's also a successful and qualified engineer, and his specialty is Firestop. He's going to talk about post-installed anchoring installation systems. He's from IIT, which is good institution, one of the top institutes in India, and Institution of Fire Engineers in the UK. So, ladies and gentlemen, today's webinar is going to be sequenced like this. I have introduced the speakers. Once that is done, then we have a presentation for between 25 to 30 minutes by Agnes Koltay, followed by a presentation by Mostafa and Muzaffar from Fischer. Let me also tell you that we will be conducting an audience poll. My colleague at the back end will be running the audience poll. We have 10 polls. Each poll has a duration of 30 seconds, where you'll be asked to give your opinion on the audience poll. Once that is over, we'll have a joint question and answer. So I would request all of you to put your questions while you are in this webinar. There is a small questions tab on your panel. You just have to click the question and you can ask the question. And my colleagues at the back end will take up the questions. I guess we will have a lot of questions, so feel free to ask as many questions as you would like. And then we'll be able to take up whichever questions we can. If we are unable to take your question in particular, your questions will be then sent to our panelists, who in then over a week's time, they will be able to respond to you. WFMmedia.com, if you are interested to see the presentation again, all you need to do is to go to WFMmedia.com and go on the webinar panel. And by tomorrow, we would have posted the live webinar over there as well. I just give you a small brief of Fischer Middle East. I think Fischer is synonymous to fixings, and everybody who's been in the facade and fenestration business should definitely know Fischer. It's a company which was founded in 48, and It has pretty much offices all over the world, manufacturing plants all over the world, 1,500 plus patents, awesome, and 14,000 products. So as you can see here, they're a worldwide company, they're a specialist, and they're a very well-known specialist in the field of anchors, fasteners, Firestop, and other solutions. This is just a viewpoint of their factories around the world. So I would now like to ask to bring on Agnes. My colleague at the back end will make her the presenter, please. And Agnes, over to you now to give your presentation. Agnes, you'll have to switch on your camera.
Okay, camera is on.
All good.
Okay, I think it's good now. Can you hear me? Yes.
Yeah,
okay,
please.
Welcome everyone. I'm very pleased to be here, and I'm very honored that you all are present to have this webinar today and to listen to us. I do not have a presentation today. I will not have slides. I was thinking to talk and maybe to have some content that brings up questions, and please put those questions down to Ahmed, and at the end of the session we can get back and respond these. Actually, Ahmed, if you see some very interesting question, you can even interrupt my presentation. I was hoping today to be quite informal and personal. So the topic I actually choose myself to talk about is high-rise buildings versus low-rise buildings, and how facade engineering is present in these two types of building categories, because it could be quite a different approach. Thank you for the introduction. Ahmed has mentioned about my company. It has been 9 years already that Koltay Façades is in business, and we are pretty proud to build quite a number of buildings worldwide, but most of them in Dubai. Actually, a large concentration of high-rise buildings in Dubai downtown, and that's the experience which is getting accumulated and makes us very focused on high-rise building specific facade engineering problems and solutions. One correction to what Ahmed said, you mentioned Burj Khalifa. I actually think you meant Burj Vista. I have not been part of Burj Khalifa. That's an amazing project, but we have not been part of that. Many other projects, though, around Burj Khalifa does carry our name, including Burj Vista, Sky Views, Address the Boulevard Hotel, Fountain Views, a couple of other buildings, and also some pretty interesting complex shaped buildings as well, like the Opus or Museum of the Future, which we were part of and very proud of that. Okay, so let's get to the topic: low-rise buildings and high-rise buildings. The main difference, I would say, is the quantity that goes on the facade. A high-rise building gives the opportunity to bring a seriously large quantity of certain system that allows us, the whole procurement chain, to provide solutions in different magnitudes than for low-rise buildings. On the other hand, low-rise buildings are much more accessible and much more easier to install materials direct from the outside without sophisticated methods. That means that for high-rise buildings, prefabrication would be a much more preferred method to bring materials together and install them on the building. When it comes to a glazed enclosure, we have unitized system and we have stick system. Stick system is the system which gets built more on site. It's a more site intense method of building, but that also means that it's less intense on the preliminary stages of assembling and fabricating the units off site. It actually arrives to site as mullions and transoms, and the glass separately and the gaskets separately, and it gets put together on the building. It can be used for high-rise buildings. It's less preferred because of the need of the external access, but if the external access is provided, such as in the case of balconies or terraces or certain type of semi-unitized enclosures where it can be pre-assembled on ground and elevated in one piece, then yes, it can be installed on high-rise buildings as well. High-rise buildings also move differently than low-rise building, and that's more something that a structural engineer can explain better. Actually, I have to say it's very difficult to speak without any feedback, without seeing the audience. I've never done it before. This is the first time, and it's a weird experience, I'm telling you, without seeing faces or hearing questions. But let's get back to it. So I was talking about the building movements. So a high-rise building, and structural engineers can explain it better, have certain behavior as a response of external impacts like wind or earthquake. Low-rise building, the structure behaves differently. High-rise building has its natural movement following these effects. With the facade cladding, we have to allow for these movements. This does not happen for low-rise buildings. It's more a high-rise building thing. So the importance of movement accommodation is an extremely big difference when you are approaching this too. Another one would be the wind loads itself. Many times we get requests from architects, developers to increase the size of balcony sliding doors, for example. Yes, you can increase it, especially if it's on a villa or a 2-3-story building where the wind loads not exceeding 1.5 kPa, 2 kPa wind pressure. On larger buildings, there could be localized spots for wind pressure which are higher than the typical, and those in the downtown area, for example, it goes up to 5 kPa easily. So the same balcony door which works for 1.5 kPa will not work for the 5 kPa wind load. It will be smaller, or it will be bulkier, or maybe it's not even possible. Fire, I wanted to mention that's also important to look at how fire spreads and behaves when it comes to a larger building. These days, it's a lot of focus on fire protection, and I think one of the presentations after me will explain about perimeter fire safing. That's again something which fire compartmentalization, the location and the sizing of these details and interfaces is something that has to be looked at with additional care when it comes to a larger building. Many times we have the question of solid cladding, whether there are any alternatives of stone cladding, GRC cladding, metal cladding, pros and cons of using these. A large part of it is actually preference, just aesthetical preference, but also each material has their own ways to deal with it, and some technical limitations as well. Stone, for example, it's a natural material. Depending on the actual stone type the team is choosing to implement, the size is quite limited. Typically 1 meter, 1 meter 20 by 60, 90, that's pretty typical stone lapse size. Can be slightly bigger, can be smaller. With GRC, much larger units are possible. Floor height, even double floor height by 1 meter, 2 meter, even larger units. The limitation here comes from the practicality of dealing with such a large unit. And also don't forget, the larger it is, the heavier it is, the more difficult it is to maneuver. So the risk of getting it chipped or damaged during maneuvering is higher. Is that really practical? Not really. So there's an optimal size, even if technically even larger sizes could be possible. Again, when it comes to maneuvering at a height with a building material piece that is hanging from some suspension, and then a team maybe in a cradle trying to push it at the final location, versus a lower building where maybe scaffolding is also possible, and a piece of GRC is hanging from a cherry picker, and the team is a bit more comfortable moving around and less restricted in movement. You could get a better result of this installation.
Agnes, I'll probably interject with a question to you to get a little bit more focus. Over the last couple of years, we have seen some fires in the Middle East area and other areas as well. So as a consultant, how more important has fire stops, fire seals, and fire protection in facades becoming more and more important to you, and the message that you could send to the entire fraternity here in terms of the importance of fire safety in facades and materials which are...
It's an interesting question, because I never ever dreamt of designing a building, even much younger, and even with the previous companies I worked with, without perimeter fire seals. So if you are in the profession, it's something that naturally has to be there. And I actually learned it as a surprise a couple of years later when some fires happened, that the fire safing was not designed to be there. The complexity of it comes that it's not purely the perimeter fire seal. It has to turn up at the vertical enclosures when it comes to certain locations, and also has to be executed on site properly. And that's something that needs trained installers and trained inspection team. Is that responding to your question?
In the sense of the fact that now that it's even more and more important, and there are the authorities there in the Middle East also pretty stringent on it, as a consultancy company, you take extra precautions while you're inspecting the building, that the fire safety across the perimeter as well as from the floor to floor level is in place, and you incorporate that in your specifications very, very importantly.
Honestly, to be honest, we exercise the exact same care that we did before. I'm happy that the importance of this question pushed the whole condition to be to have more focus and to be always inspected properly. But from our point of view, it was always an important part of the building. There are though some features which were not enforced before, and with the new regulations they gain more importance. For example, the horizontal fire barriers in the cavity outside of the building. So if you have a shear wall and then you have the GRC cladding or stone cladding attached to it with a secondary steel structure and some cavity and some insulation in that cavity, the horizontal closures are something that is good practice. It was less enforced and less common before the fire regulations came out.
And share with us, which will be interesting for everybody. Like everybody's journey is always tough to start your practice and where you are today. You share with us one of your most difficult projects and how you overcame your client and architect and the consultant and the money. And you know, it's important. Everything looks very rosy in front of it when the building is over, but the pain that you went through and you fought for quality and you won over that.
You see, I don't have a favorite project. I actually have many projects that I like that we worked on, and that's one good thing about the previous period and the abundant number of projects we had in the UAE, that I could actually choose projects to work on where architecturally we were inspired to work on. My experience from all these years, every project has some difficult person. It could be on contractor side, it could be on the client side, architect side, and on some projects maybe I'm perceived as the difficult person. It's a personal thing, and I don't think that it should influence the outcome of the project. I think if the team is watching the benefit of the project, then the project will be successful. So a building is designed and built to be there for, depending on the function, minimum 20, but typically a 60 years design time. So the main structural elements are even longer, and you want this building to perform well during this period. And during this period, there could be wind events, earthquake events, unexpected temperature extremes, and the building has to withstand this. And it doesn't really matter if there was a meeting or two where people had a bit of difficulty. At the end, if that building performs well and investors or owner or operator finds that the building skin is doing its purpose of closing off the external environment and protecting well-controlled internal environment, and that means solar control, temperature control, air, dust, noise, fire, all these, water as well, then the building is successful.
So one, I'll probably put another question to you, that as a consultant here, and you've been working here in the Middle East for quite some time, as a consultant, what would you like to tell the whole community which is joined here from the GCC? We have over 350 people listening to us right now. As a consultant, if you have a concern to clients and developers and architects, what would you tell them? Not just that they should listen to you, what you tell them to do in terms of the design. What requests do you have?
I'm not really sure what to say. I mean, I like to work on projects where the team has a good understanding. When you know, I don't like politics. I don't like things which have second interior intentions. I like to be very straightforward, and I like when things are handled in an honest way.
But you know, people always try to play around and always try to twist the game, and there's a blame in projects which happens all the time. How do you overcome as a consultant all these difficulties, if at all?
Well, you see, that's what I try to say, that there are technically correct ways. I'm not even saying that there's only one technically correct way. Sometimes things have, many times in life, things have different solutions and different ways to look at it. And actually, there's no such a thing really as a correct solution. There's an optimal solution for the given condition, and that condition is the function of the building, the project budget, the aimed use and quality level of the building, the time frame. So that optimal solution, if people in the team are representing and working towards an optimal solution, then at the end it will succeed, and there's nothing else behind it.
So just be straight, be simple, be straightforward. So going forward, we still are, I can't say it's post-COVID, because COVID is still pretty much around, and hopefully, inshallah, that it will go away one day. What do you see? Do you see any structural change from a facade perspective going forward in terms of how buildings will be designed, or how they will be, kind of?
I think there will be a general change in the whole, and we are already witnessing a change in the whole development mix, which and the magnitude and intensity of that development mix. As we go ahead in time, there are different needs and demands in Dubai and in the region, and that will change. Also, there is an interesting restructuring process going on with procurement. And while in the past it was more frequent to have here a traditional procurement route where the design team designs everything, the facade consultant comes up with the specifications, drawings, it gets tendered, the main contractor gets it, and then there's a facade contractor either coming with the main contractor or nominated and selected separately, and then they all work out the design documents, I mean the construction document, shop drawings, and build the project. Recently, it's more and more designed and built type of project. I mean real design and built, not. I don't mean when the design is tendered out at an early stage and then getting finished while the contractor is going ahead. I mean when the design is handed over to the contractor and the contractor's team is building solutions. So I see that maybe becoming more frequent.
And there are still a lot of jobs, or I guess there'll be fewer in terms of the requirement today, but going forward from the GCC area, do you still get a fair amount of queries for newer projects?
To be very honest with you, we see the exact same amount of queries as in last year. The big difference is making decisions and awarding those projects, which we see much slower than before, and that's probably also the carefulness that this COVID uncertainty brought to everyone.
But there is still a positive hope for development and more scrutiny on the project and more careful of things. And then from a perspective of fixings, fire safety, all of this, you think going forward will become more improvised or more important? safety as an overall subject?
Yeah, I mean, it's always a target and always an important thing. Whether it will be more important, I think if it was not important on any projects before, yes, it has to get important. But it's something that that should be important. I mean, the volume of projects will reduce, and there's a great big range and selection of already completed buildings or near completion buildings, which is available for investors. So there is a harsher and harsher competition, and in that competition, building performance, safety, reputation, general reputation of the developer, of the designers, of the contractors is more important, should become a more important factor than before.
Like you said, there is still queries coming, and the similar amount of queries are coming, so work is still going to be there. Of course, for the next 3 months, I guess there'll be lesser, but then we all hope and believe that things will be better in the future.
You know, Dubai is a place for optimist people, and that's one thing I enjoyed living here for 15 years. I have this theory that in Dubai, people are generally happy because whoever is not happy would find another place where he's happier.
Yeah.
So yeah, there's always optimism. Let's see what comes out of it.
Right. You have any closing remark, or I'll move to the next presenter.
Okay, well, I do hope that I do get questions from the audience on high-rise buildings and low-rise buildings. I wanted to mention about each system, which is definitely a solution more appropriate for low-rise buildings. I wanted to mention about stone fixing methods. Wet set stone where it's glued to the wall is something that should be only used on basically ground floor areas, only a couple of meter height. And mechanically fixed stone is something which should be on higher elevations, but again it needs to have certain type of engineering, and also the stone material is a very important factor in it. And I started to talk about potential alternatives and how stone can or cannot be substituted with GRC or precast or EIPS or other materials. And you know, if anyone interested and have a specific question, then please do so and put it in the chat.
Yeah, we'll take the questions towards the end of the seminar after the next. Well, thank you very much, Agnes, for sharing your experience, and still
welcome.
And stay there while the other come on board. Thank you very much, Agnes.
Thank you. Thank you.
You're very welcome. Request my backend team to please put on Mustafa's screen here. And Mustafa, maybe you can reintroduce yourself a little bit, and the floor is yours.
Hello, Assalamu alaikum. How are you again? Thank you, Ahmed, for your nice introduction. I would like just to highlight one more thing. Before I joined Fischer, I worked also 7 years in facade industry. So after that, I joined Fischer in 2010. So I have both experience, fixing experience and facade experience as well. I would like also to thank Agnes for the nice presentation. And now, after her presentation, we know that fixing system is important for high-rise, even for low-rise building. In the past, there was a need for mechanical fixing, and one of the most famous mechanical fixing for stone is called as bin system. But still, this system, it has a lot of challenges with the consultants and with the designers. Some of the main challenges, one main thing is the thickness of the facade. As we know, we have to fix the fixing on the edge. So the edge is very important factor, and minimum I think is 30 mm for soft material and 20 mm it can work for hard material with care. Second more important factor is the offset from the wall. Usually we have a small sizes of stone, and when we have big distance or big offset from the wall, I don't have always concrete to fix my anchors. So what will happen? I will have a lot of anchors on the bracket and on the anchor as well, and I might have here a masonry which will create a need of some time for a secondary steel structure. The third challenge is the type of the wall itself. Sometime we have a concrete, we will be happy, and also a lot of times we will have a masonry, and sometimes we'll have also white masonry which is weak. These challenges we face in the design stage, but this is not the only challenge. If you focus in the screen now, one of the most important real challenge for the bin system is how to install it in the site. Usually, because they have to fix the bin on the thickness, so they have to drill in the side of the panel. Laborers, to take care that they have not to scratch the surface of the stone, they go a little bit backside and they drill on the side. When they do this, unfortunately, they do some failure to the panels, and they take the easy way by put some repair for the stone or some epoxy and fix it. What happened here? The system not became a mechanical system, it became a mechanical system with glue. And it can cause a failure or safety in terms of when we have a thermal expansion, or also after the time with high temperature here in our region, the glue here can change. So we can have also a failure due to after some years of gluing problem. So due to that, Fischer took this requirement of our client into consideration. And as we are a specialist on fixing from 1947, we start to develop a system for stone fixing in 1973. It was our first stone fixing. Then from that time till now, we developed our undercut system successfully, and Fischer, a market leader in fixing, we are selling yearly more than 2 million meters square of facades. We have also more than 1,000 international reference in the worldwide. You can see here on the screen some of these references. Fischer improved, or Fischer developed a system which we can call it as a universal system, universal mechanical system, because it can work for thick stone, it can work for thin material. This advantage of working of thin material and thick material makes the system can use for different materials, not only stone. It can be used for stone, it can be used for ceramic, porcelain tiles, natural stone, fiber cement, GRC, HPL, any material which thickness is more than 8 mm. We have a good solution for this. This gives our clients, our architects, a lot of wide range of solution to find the suitable, to use the suitable or the beauty of the materials in the facades. How the system is work? The system idea is easy and professional. System idea is to create an undercut hole in the stone. Means the hole inside the stone is bigger than the hole outside the stone, and transfer the actions, wind load, weight of the stone, whatever it is, from outside the stone to inside the stone. The drilling mechanism is easy. By straight drilling, then the drill will rotate to create the undercut conical volume inside. Then installation of the anchor will create a stress-free installation, because the clip will open exactly in the volume what we created. So there is no any additional stress on the stone. I also want to show you practically how it looks. So this is a real piece of transparent material, and here is the anchor in front of you. Now we are going to install the undercut anchor in this thin material. It's 10 mm only, And you see it is freely installed inside without any damage to the material. If you take a deep look, you can see the clip is just moving inside. Sorry. You can see the clip is moving inside here. Even the distance to the edge of this material is very small. We don't have any cracks or any stresses happening in the material. That's how it is going inside. To understand the benefit of our system, we created a structure comparisons between pin system and undercut system. You can see here two different panels we modeled in finite element software. A structure engineer can understand how this can be modeled in the software. You can see here this panel is with pin system and this panel with undercut system, and all other conditions are same. We did not change either the panel size or the wind speed, wind suction, or whatever it is. When we do the comparison, you can see here the colors of the stress diagram. So you can look here that how much the stress is very high in terms of pin system. It reached almost to 56 megapascal, while the stress here for normal system is only goes to 20, between 12 to 24 megapascal. That means we can reduce the material stress, the stress on the material by almost more than 50%. We made a conclusion for this. We did a lot of case study, not only one case study. Some with height to length ratio 1 and one with height to length ratio 2, means a square panel and a rectangle panel. And we measured or we checked how much is the deflection, how much is the undercut moment, and we checked. We found that the moment of the undercut related to the moment of the edge is almost only 36% out of it. What does this mean? It means that we can reduce the thickness of the undercut if we have a panel of 50 mm. The thickness can be reduced almost to 30 mm only. And if we have to design with a stone or with a facade panel of 30 mm, with undercut, you don't need more than 18 mm under the same conditions, under the same loads, under the same sizes. So this gives us several benefits. Either we have a better loading or we have bigger panels. We can go for a better panels. We don't only do theoretical installation, but also, or theoretical demo or simulation, but also we make a practical ones. So here you can see we did some seismic test. So under the seismic wave and impact loads, the stone is moving, but nothing is happening to the system. The stone is safe under this high loads. Of course, if you are trying to do this with bin system, is very challenging. So we do a lot of simulation, a lot of engineering, a lot of practical tests as well. This gives us a lot of benefit to our clients. Instead of having a very high weight of stone, you can have a lighter one. This gives direct benefit of reducing the total cost of the system. So you just imagine the main cost is almost the stone. We can reduce the cost of the stone by almost 40 to 50% direct on the material. Also, if you have a project, for example, of 6,000 meters square, of course, before we start, we have to plan our logistic area. We have to plan storage on the site, how many containers we have to buy. All this logistics, storage, all this can be direct reduced by 40 to 50% by only making better designs, by reducing by choosing the correct fixing system. Also, reducing the weight is very important. You can imagine when the labor is lifting panel which is 100 kg weight is easier for him to lift a panel which is only 50% of the weight, half the weight. And I can give you one practical example from indirect cost. When we have to design a structure from a structure point of view, and we have in this structure 6,000 meters square of limestone, if we have 50 mm 6 stone and we have to design it to use it pin system, the total weight of the facade will come to 660 tons. But if we can reduce the thickness of the stone to only 30 mm, then the total weight will be 396 tons. This will reduce the weight of the full building by 264 tons, which is a very huge saving in terms of structural system as well. So the system has a lot of benefits from a structure point of view, but we don't only focus on structure as well, we focus also on architectural point of view. We know that consultants like Koltay or like all other consultants, they love to see the natural of stones, a natural stone on the facades. So the problem it's faced that the thickness of the stone can vary because it's natural material. So we developed a system which can work for artificial stone and as well as natural stone, even if there is some tolerance in the panel. The idea is the distance from the facade to the fixing point of the anchor will be always constant. And in between, it can take whatever difference or variation in the thickness it is. So this will lead to less work in the site for adjustment and better, amazing looking from facade architectural point of view. Our main aim also in Fischer, not only the product, but the quality. So when we developed the system, we developed also an easy way of quality check to be sure that the system at the highest level of quality. So this tool is very easy. You can just put from one side, it gives you that hole is okay. And from the other side, it should not go, so the hole is okay. And this is called a volumetric check. So these tools you have to put inside and click. If you see the red mark, that means the hole is not okay. If it is not visible like here in the video, means the hole is fine. So also the quality check is not required a high-end professional engineer to do it. It can be done easily by our system. So this how it looks after installation. We can supply here in the screen the full system, not only the anchors or not the undercut anchor, even the aluminum profiles as well. As a conclusion, I would like to highlight that our system can have a benefit of saving time, a benefit of saving cost, and high level of quality and safety, and also it helps our client with the architectural beauty they are looking for the system. Not only our benefit is limited to that, but also we are developing our BIM families for the facade with dynamic model, which you can just copy on your facade BIM drawing and extract, and it will automatically take the measurement of the facade and put the details of the frame, anchors, undercut anchor, everything. So it is very easy and fast for our engineers to do. We as Fischer provide a full system, not only aluminum system or anchor system, but also we have a Firestop system. So this is here I'm ending with the stone facade fixing system. My expert, Mr. Muzaffer, will speak more about Firestop system for facade to explain to you all our services in terms of fixing and also Firestop. So I would like to ask Mr. Ahmed to hand to Muzaffer.
Thank you so much. Very interesting. I loved your videos in which the anchors are actually showcasing and how they work. So I think, of course, Fischer is a great company and they do have all the German engineering in place. I now take you over to Muzaffer. Muzaffer, the ball is yours. You can share screen now and take on your subject. You have another 15 minutes. between 10 and 15 max.
Great. So I think my screen is being shared.
Yeah.
It's visible? Yep, great. So just a small correction. Thank you for a very good introduction, Mr. Ahmed. Just one small correction. I am not from IIT, but a member of IFE, Institution of Fire Engineers from the UK. All right. So after an interesting talk with Ms. Koltay and an interesting description of the support systems, the aesthetics has been addressed, structural safety has been addressed. The only remaining primary concern in terms of safety in facades is the fire safety. Now, generally, the chances of ignition of fire within the facade system is negligible. However, the spread of fire becomes a significant safety concern, which was voiced by Ms. Koltay also in her discussions. So let us discuss in detail about this. Now, before we start, let us consider the fact that in case the facade is exposed to fire, why do we need to consider fire in facades? Firstly, the facade support system loses structural integrity. Now, this results in falling of burning objects, which might pose a massive risk of injury as well as igniting secondary fires. Now, this image here, this image here shows an example of a facade fire that occurred in the upper floors. So as you can see that the fire was only in the upper floors and spread upwards. However, the devastation caused by the falling debris could be seen in this image. Secondly, there is a significant risk of propagation via the facade system itself, and we will discuss this risk a little in detail, keeping within the time allotted for this segment. Here I have a small video how a fire starts in a lower level, spreads via the facade surface, engulfing the entire facade elevation within a very, very short time. The speed and the extent of the spread of fire depends on several factors, including the facade material, the fire compartmentation, among others. In this case, we could see it took a very short while for the fire to spread to the highest floor. Now, once spread on the surface of the facade, the fire could quickly re-enter the upper floors, thereby ruining the entire passive fire protection of the complete building. Facade fires have been witnessed in several significant buildings, most recently in the Apco Tower in Sharjah, UAE. Now, improperly sealed perimeter joints or cavity barriers and use of non-tested materials cost lives and huge liability losses. This is the reason why this fire safety in facade is a primary concern for many people. Now, we as Fischer help in the fight against the propagation of fire and ensuring the compartmentation is maintained, thereby saving lives. I would like to quote our owner here, Professor Klaus Fischer, who said that safety is the primary concern and we would never put safety on the line for business purposes. That being said, for an easier understanding, we look at two main types of facade we encounter in high-rise buildings, namely the curtain wall and the ventilated or Rainscreen facades. Curtain walls are an outer envelope of the building. The buildings with curtain walls do not have an external structural wall, and these facades are generally governed by aesthetics and are responsible for shielding against the external weather elements. On the other hand, the ventilated facades are also an aesthetic skin over the building structural wall, and they also aid in overall insulation of the building from the weather. Now, there is a ventilation gap behind the facade itself, and let's look at what are the fire safety challenges in both and understand how the fire spreads in either of them. So what I've done is, this is a section through a building with a curtain wall facade installed on one side and a ventilated facade on the other side. when a curtain wall is exposed to an internal fire, the first route the fire and smoke spread is via the unprotected gap between the slab and the wall. Now Fischer provides a solution to close this gap and prevent the internal spread of fire and smoke. However, there is a second route the fire could take, that is from the external side after the glass panel have broken under extreme heat. This is known as the leapfrog effect and is affected and is dependent on the type of the facade, the size of the spandrel panels, and other active systems in place. Now, on the other hand, the fire behavior in the ventilated facade is slightly different, as in the internal fire could reach the ventilated facade system via a broken opening like the windows or doors in the structural wall. The fire would rapidly propagate within the ventilation gap, and this phenomenon is known as chimney effect or the stack effect. Now Fischer protects against this propagation of fire in this gap. Again, there is a second route the fire takes to spread via the surface burning of the facade material itself. And this is again dependent on the characteristics of the facade material itself. Now, there are codes and standards in place to address this fire behavior as well. So the summary of the code requirements for curtain wall facade is to ensure that the fire rated floor is extended to prevent the internal spread of fire, and then the minimum spandrel height is as a guideline to take care of the leapfrog effect. Now the code issued by authorities have jurisdiction. Example, the UAE Fire Life Safety Code also has detailed guidelines on this with a similar intent of addressing the internal as well as external spread of fire in the curtain wall facades. Similarly, for ventilated facade, the code requirements ensure the compartmentation within the ventilation behind the facades to prevent the spread of fire via the chimney effect, and also there are guidelines on the facade material to restrict the spread of fire via the surface spread of facade of fire. Sorry. Now, the code issued by authorities having jurisdiction, again, for an example, we take the UAE Fire Life Safety Code, also has a detailed guideline on this with a similar intent of addressing the spread of fire within the ventilated facade systems. Now, finally, just to give a quick peek into the solutions that we provide, we have several listed and tested systems with international testing and certification bodies like the UL, Intertech, or Warrington Fire, etc., for systems designed for perimeter fire barriers in the curtain wall facade. Now, we could offer a spray type sealant solution using the RFS or FFBES over the stone wool backing, or a dry type of system using just the Fischer FCFCL. Just to briefly show you the application of the wet system, which is a very fast and effective way of providing fire barrier in the perimeter fire barrier systems, where the backing material is placed in and then the sealant is applied using a spray equipment. Now the RFS comes with a cutting edge system with just 1.6 mm of wet film thickness for a joint of up to 200 mm width, which has considerable saving in terms of the material. This is the finished look of how it would appear once the fire barrier is in place. Now, just to give you a brief comparison between the wet system and the dry system for fire stopping, there are certain underlying parameters that are affected and should be in consideration before deciding a particular system in a project. Now, for example, there is no water resistance offered by dry system and the movement capability is severely limited. Also, the logistics and the storage cost will be higher due to the increased space taken up by the product used for the dry system. On the other hand, the RFS-based wet system aces in all the parameters except the speed of application, as this requires a two-part installation of the backing material and the spray system itself. Lastly, we look at the solution that we provide within the ventilated facade system. As it could be seen in the image, this is the structural wall, and then you will have a facade coming over the compartmentation generated by the product itself. So the vertical compartmentation is provided by Ventistop, which ensures the ventilation is present in normal conditions, but would close once there is a fire incident happening within the facade. Also, the horizontal compartmentation, as required by several codes, is provided by the FCFCL system. Once this is in place, you can just place the facade over this, and you are sure that the compartmentation is in place behind the facade itself. Finally, just to reiterate that we, as a service provider and a partner, do not just sell products. We always talk about complete service, which includes all the products which would be required to support your facade and provide the fire safety required. Then we also do this design calculations associated with that. We customize the solutions as per the site requirement, including the engineering judgments required for fire stopping. And then we also go the long way by providing on-site support, demo, and hands-on training. This ensures a peace of mind for all our partners. Now, I would request our host to play our video.
So I'm going to go on to a few questions. There are about 70. Wow, so many questions. So I'm going to take up the ones which I, not the most technical person around town, but I'm going to give it my best. There's a question from Nada Chami. This one's for you, Agnes. Does Koltay Facade explore lightweight solutions to reduce structural load and embodied carbon in high-rise building projects? If yes, what are the main challenges going lightweight?
Yes, it depends on what's the aim of the project and the developer. In some projects, weight is not one of the major considerations. In some other projects, the main structure has certain limitations. To tell you a good example, Museum of the Future, it's a donut-shaped building and it's steel structure, and the weight of the facade does matter a lot because it's pulling the structure down. So depending on the shape and structure of the project, it can be a very serious or not as important consideration. Also, it's important when it comes to building. It's echoing for some reason. When it's an additional building, like an additional floor on an existing building, or using an existing structure in a renovation project and putting something else, then in that case, weight is very important. Embodied carbon, that's a complete separate topic, and yes, again, it depends on if there's a sustainability drive for the project, and it is one of the aspects to focus, then yes, it will be researched.
Okay, great. Maybe this is another follow-up question. This comes from John Garcia, who is asking if XPS, expanded polystyrene, is still being allowed in wall of facade or roof if it passes burning characteristics and smoke spread requirements.
Is it to me?
Yeah.
In different countries, there could be different local regulations. Here in the UAE, I don't believe that it would be allowed. I have not seen it around for quite some time.
Okay, so pretty much the answer is, so John, the answer is pretty much no. There's a question about any solar energy update for buildings coming up in the future. Perhaps, Agnes, you could answer that as well.
Say that again, sorry.
In terms of buildings which are more solar efficient, this comes from Muhammad Abul Taif, if I've got your name right.
Okay, so solar efficiency can be most efficiently increased by adding external shading. If you add external shading, you introduce a lot more maintenance problems of cleaning and keeping those external shading devices clean and in a working state. So it's a trade-off. There's an optimum. There's also the orientation of the building, which can be studied, and then there are additional levels of solar protection, the fenestration ratio, maybe using less transparent glazed surface on the building, and then if you use then selecting high performance coatings in a way that they have a very good solar performance. It comes hand in hand with the visual light transmission properties of the glass. Very, very good solar transmittance tend to influence the light transmittance, but there are newer generation glass coatings where a very good selectivity number can be achieved, which means the light transmittance, visual light transmittance is still preserved, and the solar heat is cut off quite significantly. So there are different approaches, different techniques.
Thank you.
It has to respond the aesthetics, the aesthetic vision of the building.
So there's a question for both Agnes and Mustafa. The question is from Edwin Augustin, who's saying, what is your opinion on the pin type fixing for stone facades? Mustafa, you can start this answer.
As I explained in the presentation, bin system, I cannot say it's a bad system, it's a good system, but there is a challenging when you come to bin system, and there is a lot of limitations. So what we did in Fischer, we have a solution which can go across all these limitations. Main limitation is the size of the panel, thickness of the panel, all this limitation is there. So we have to take each case one by one. And when we have a case which we need a thin material, or we need to use a big stone panels, then we should not think for the bin system, in my opinion. What's your opinion, Agnes?
My opinion is pin system is the traditional way of fixing stone, and it has been proven and tested for long, and it can be done well. But as you mentioned in your presentation as well, it has to be done with care, and it relies heavily on the workmanship on site and the installation of those pins the right way. The undercut bolt technology is safer and less visibly disturbing. You can go with smaller joint lines with that system. Where you need to account for the thickness of the pin plates in the joint for the pin system, for example. But the contractor has to invest a little bit to get the right drilling bits and the right machine to be able to install it. What I also really like about the undercut bolt that it can be used with other materials as well, with glass as well, and that's a nice application.
Okay, thank you. Mustafa, another follow-up question. Maybe it's either Muzaffer or Mustafa. The question from Munir, who says, do you run any heat load calculation to ensure that the size of the stones or covering the facade is properly selected for the building? What is the U value of these sheets you provide?
We don't do the U value calculation, but we do the calculation for the thermal expansion of the aluminum system and the stone to be sure that there is no any additional internal stressing. The joint width is okay to ensure that there is no clash when there is thermal expansion or contraction is there. This is one of the main factors which can cause safety and failure in facade, ignoring the thermal expansion and contraction for the stone itself and for the subframe. So this one Fischer take care in the calculation, and we can provide the complete technical solution. But regarding the calculation of the U value, we don't do because there is other material are involved, which is not from Fischer, like the thermal insulation itself. What is the supplier? Who is the supplier? From where? And also the brick material or the facade material. I mean the wall material itself.
Can I respond this question as well? Mechanically fixed stone system should be installed and designed as a Rainscreen system, which means it's open jointed and ventilated. So there's an air gap behind, and air can actually move through the joint in that gap. Even if some joint may have some filling, the overall system has a ventilated gap. For the linear U-value calculation of this type of systems, usually the stone layer is not taken into consideration because there's ventilated air behind. So you start the U-value calculation with the insulation. It's a conservative way of approaching, because there will be a little bit of shading effect and insulation effect of the stone, and that's slowly moving slightly ventilated air behind. But to be on the conservative side, the typical way of calculating it is not taking the stone into consideration, not taking the air gap into consideration, but start the build up from there. So as Mostafa mentioned, their part of this whole build up is just a small portion. There are other layers, and that's typically the facade consultant or the facade contractor who has this overall responsibility for looking at these materials and structures come together as an integrated system.
Okay, I guess Muzaffar, there are quite a lot of questions on fire there. I'll take a few of them. What's the technical difference between RFS 640 and FFBES? Are they compatible? Can we use it interchangeably or adjacent to each other, or we can patch them? That's from
yes,
Edward.
That's a good question, Edward. That's a very good question. Actually, these two products are designed slightly differently, and they are in compliance with two different standards. So there is the American standard of testing, and there is the British standard of testing, European standard of testing. So FFBES is predominantly a European product, which are tested thickness of 2 mm minimum requirement. Then we have the higher product, which is RFS 640 with a 1.6 mm thickness of sealant. And no, they cannot be used interchangeably, as they are tested to different test standards, basically. So they'll be independent systems.
Okay. Are these UL tested or listed?
UL as a laboratory, it is both a testing institution as well as a certification body. So we have systems which are tested under the UL as well as listing scheme under the UL, and both these products have certifications from the UL listing, one under the European norms certification, and the RFS under the European UL American certification scheme.
There's another follow-up question on that, goes to you only, Muzaffar. For a Firestop, there are two questions actually. What's the lifetime of the product once you put it in place? And second question is, what guarantee does Fischer offer?
Well, the product is age tested. So all of the Firestop products are required to be age tested, and our products are tested up to 30 years of age, life expectancy. And related to guarantee, it does guarantee or warranty is a very misunderstood topic, because it depends totally upon several factors, including how they are being applied. So once the product is applied, you can expect a product life expectancy of 30 years. And then if it is applied correctly, it will function correctly for 30 years. I think that would make sense.
Okay.
Yeah.
This is a question from Vaim Eid. He says, he or she, can you please advise why is the new trend of having very high light transmittent glass options in such areas as GCC? If that is the correct question. Agnes, perhaps you could answer that one if you know the answer to it.
I'm getting the difficult ones. It's I wouldn't say it's a new trend. I mean, I have been here since 2005, and Sheikh Zayed Road was full of glass buildings those days as well. Whether it's the right approach or not, it's quite an aesthetic question, and many times the architect makes the decision based on, or the developer, architect and developer team makes the decision based on what they want to express with the building. Transparent glass buildings are have a different notion, a different secondary meaning than a more solid building. Local patterns on a building have a different feel than I mean the Islamic geometric patterns or like straight lines or patternless buildings. So these are all aesthetic decisions more than performance governed decisions, at least in the past 2-3 decades. It has been like that in the Middle East. But again, there are extremely good glass coatings with extremely good selectivity and high performance. It's still different than having a masonry wall or a solid concrete wall with insulation, of course. But it could be a bit misleading to see a glass building. It does not mean that it's a complete waste of energy.
Okay, take a last couple of questions and then we'll wrap it up in the next 5 minutes. Perhaps I think Mostafa would answer this one. For the bolt type fixing for stone presented by Fischer, how would they manage if the base of facade is not straight, mainly due to the constructional errors or limitations? Will this call for additional usage of runners, or there are tolerances? If yes, how much? This is from Abhishek Sharan.
Yeah, this is actually a really very good question. That's why Fischer we have our runners mullion and transoms, which it has a tolerances which we can give to the system. Usually we prefer to give plus or minus minimum of 20 mm, but we have very wide range of sizes of brackets and with vertical profiles, which we can match both together to reach whatever tolerance they have in the building. It can be managed by our frames.
Okay. I guess as I keep asking questions, there are more and more questions coming up, which is good and bad in a, but I'm not a specialist, so I'm going to give it my best shot to ask. Muzaffar, this one's for you, buddy. If the pipes within the facade panels, if I have pipes, this is from Munir Jode. If I have pipes within the facade, why I have to use collars only? If I have a slab edge provision which allows me to fix pipe and put the sealant around, is there any direct system, or we should go with engineering judgment?
Oh, well, this is a good question, because here there are two problems. One is you have something called a penetration requirement, and then there is a joint requirement. So the question number one regarding collars, collar would be only required if it is a kind of a combustible pipe, right, to close that gap. However, now when you have this kind of mixed up system, then the only solution would be to go with an engineering judgment with a product which is tested for both joints as well as penetrations, like the RFS 640, which is an all-rounder, which is having a lot of testing behind it for penetration as well as joints, where you can combine these two together into an engineering judgment.
So it's a little bit of both, right? Using your brain and getting the right product to work with it, I guess.
Exactly. Using the right product and the right testing behind it, and then combining that with an experience, and then coming up with an engineering judgment for that.
So another one for you as well, Muzaffar.
Yes.
This is from Adrian Jones, who's asking, we are still seeing a lot of ACP used in this region with wet seal joinery. what is the panel view of the fire spread propagation risk on the facade surface from these sealants? Does the use of this sealant and applicable backer rods not undermine the fire rating of the panel materials and the design system? If so, why is it still being used? Good question, buddy.
Very, very good question. So if I understood it right, they are talking about how the sealant as well as the backer rod is actually adding into the propagation of the fire within the ACP panels. So to answer that, first of all, let me tell you that ACP panels and the ventilated facade system as a whole is always tested as a complete system under any of the testing schemes, be it the NFPA 285, which gives a testing of the spread of the fire over the panel. So in that system, when you go for the testing, you have to include, number one, the panel itself, the subframe itself, then the joints between the panels and the backer rod behind that. Being said that, then we have sealants which are fire rated that could be used along as a system. So if the system is passing under an NFPA 285 test, then it will be certified to be used for the usual application. However, we do not want to use any non-fire rated sealant or non-fire rated backer rod, which would add on to the fire, which would automatically fail the NFPA 285 test.
Okay, I'm gonna take the last question. I'm sorry, ladies and gentlemen, you have a lot more questions. First of all, before I answer the last question, all the presentations that we have shown will be shared on wfmmedia.com. For those of them who would like to access them, we will put them up by tomorrow. Please bear with us. And also the names of the presenters, Fischer and Agnes, are there. If you would like to reach out to them, if it's okay for them, kindly do reach out to them. Sure. The questions which have come from you, we will send out to them so that whoever can answer those questions separately on a call or on an email, they will take it forward. And I take a last closing question. How much, Agnes, this one's for you, I guess. How much is the drop? How much is the drop in sound reduction due to the aluminum framing on the facade system in general? Say my glass has a 42 dB RW. What will be the expected overall sound reduction, including a facade framing?
Okay, there are some rules of thumbs for this, but it heavily depends on the type of the framing as well. And actually, unitized system where it's a male-female mullion coupled together and there's a soft gasket in between tends to behave a bit better than a stick system, which is a box. Where's my camera? A box section continues inside outside. You can also improve the acoustic rating of it by acoustic consultants sometimes advise on stuffing the empty mullion with some kind of rockwool type material. It can be done with stick system. It cannot be done with unitized system because it blocks movements. So it heavily depends on the type of the frame, but there is a reduction. There's also much more reduction if it's an opening window or opening door than if it's a fixed glazed structure wall.
All right. I think thank you to all our attendees here from all over the GCC. It's been a pleasure hosting this webinar today from WFM Media. As you can visit our site, let me add 1 minute before I say bye. We're actually working on building the world's first and the world's largest virtual community for the window and facade industry worldwide. And you will hear more from us and more about it in the next couple of I guess by August, we would like to present this to the worldwide audience where people, architects, clients, consultants, buyers, and suppliers can get to talk to each other, can communicate with each other, can actually have a call together, have questions and answers together, and actually build the world's first real-time virtual software related virtual community built on a very nice software at the back end, which we've been working on for the last few months. With that, I'd like to thank Agnes once again for joining today. It was brilliant. I think the Q&A, I should have started from Q&A right from the beginning.
Yes.
Mostafa, thank you very much once again.
Thank you.
Muzaffer, Thank you. I'd like to thank my team at WFM Media back here to have organized this show, and we've had a wonderful last 1.5 hours. With that, good evening, have a nice rest of your day and the whole week. Good Hafiz, and namaste from here. Thank you very much.